enterprise-level threat hunting with Jupyter Notebooks. If you aren't familiar with what Jupyter Notebooks are, you will learn about that today. We'll talk about some analysis techniques to do with that as well. And we'll go into who I am, but my name is Burke. So the quick agenda, of course, who am I? Diving into why you should listen to me, why you should even be here listening to me, right? We'll talk about what is threat hunting. I often find that many people don't have a level set understanding of what threat hunting is. So let's foundationally assign what that is, and we can build upon that concept. We will also talk about the Hou or H4A threat hunting methodology. This is just one of many frameworks that you can use to perform threat hunting. And then we'll also look at a case study with malicious PowerShell. We'll look through actual live data that I got from somewhere that I can't say. And we'll look at what potential malicious activity looks like and how we can hunt through that data using Jupyter Notebooks. So first and foremost, Burke, that's my name. I'm a senior security consultant at Mandiant, and I'm also an instructor at University of Houston. See a lot of students today, which is great. You all get A's, just kidding. Yeah, 2 jobs, 2 roles, perform a lot of security-related work from a theory perspective within teaching, but also practical use of it with actually being a consultant, right? So 5 years or so, give or take, kind of all blends in, but 5 years or so of experience. Primarily what I'm doing right now at Mandiant is I'm assisting our clients in building their threat hunt programs. So a lot of our clients want to become threat hunters or want to introduce threat hunting into their security program. And so they come to us and say, hey, we need help doing that. And so we start from a foundational level and improve upon that and introduce security and threat hunting into their ecosystem. My little fun fact, which is also a nerdy thing about me, I'm also a network traffic analysis enthusiast. I don't know if anybody watches the Texans, but it's terrible to watch right now, right? So what I like to do is, to get some sort of benefit out of wasting my Sunday watching the Texans lose, I will download malware PCAPs and use T-Shark, which is the command line version of Wireshark, and just run through it and try to analyze data on the command line so that when we inevitably lose, I also win personally because I'm bettering myself analyzing network traffic, right? So I highly recommend that. Don't just be sad on a Sunday. Let's improve ourselves, right? All right, so what is threat hunting? Here is a very over-engineered dictionary definition of what that is. It is a methodical, use case-driven process to find threats by applying our understanding of their TTPs to discover entrenched threats that have bypassed our traditional detection mechanisms. A lot of words there, a lot of that doesn't really help too much, but we'll dive into each one of these components to kind of see and uncover what it actually means, right? So when we're performing threat hunting, we like to think like the adversary. We want to understand the attack pathways that attackers will take so that we can look for artifacts of compromise of some sort within our environment. And part of that is understanding our own organizational weaknesses. So this isn't a day one, I just got to my new job at a new company and I want to start threat hunting. You can try, but it's not going to be too beneficial for you. What you want to do is have an understanding of how your organization is laid out, understand what weaknesses you may have so that you can look for artifacts that might prove your hypothesis correct or disprove it. So we have to think like an adversary to understand what the attack would look like. We also like to understand the TTPs of an attacker as well so that we know where to look for malicious activity. So if I have somebody who comes in who doesn't know when somebody schedules a task for persistence, how does that look on an endpoint, right? How does that get captured in log data? If they don't have a foundational understanding of that, then we're going to have issues performing threat hunting, right? So having that understanding of the adversary, understand how artifacts get left on devices, all that is extremely helpful when you're performing threat hunting. We're also looking to uncover previously unknown threats. So we're not waiting for a traditional IDS, IPS, or an EDR to say, hey, bad stuff happened, you should investigate me, right? We're just looking at a bunch of needles in a needle stack, trying to find the one needle that would help us some sort of malicious activity uncovered or non-malicious, whatever the case is. But we're looking for what isn't defined yet, which is a bit nebulous in scope. It's kind of hard to really lock down what the scope of a threat hunt will be, because whatever strings you pull on, some stuff might come up and you might need to start investigating that, right? And there might not be a threat intelligence report or a document from somewhere else that explains exactly what to look for. So very important. And then lastly, once we do uncover stuff, we want to improve our detections by codifying those hunts. So if I find activity that is not defined by Mandiant or CrowdStrike or whoever, and we uncovered it, maybe it's a specific malware designed for our organization, how do we detect that moving forward, right? So we need to codify those hunts to make sure that this hunt led to a successful catch of malware. Let's now detect that, so now moving forward, we can just get our automated detections from our SOC, our SIM, and we don't need to go through this whole extensive threat hunting process to find the same thing we found a month or two ago, right? So why do it in the first place? So dwell time is a big component of this, right? Dwell time has been progressively getting shorter and shorter, which is great. That's a win for us in the security industry, right? But with threat hunting, these detections don't really exist yet. They're bypassing our detections, so the dwell time is relatively high when we're talking threat hunting. So we're trying to reduce that by being proactive and just going out and collecting artifacts and trying to find malicious activity of some sort. We're also going to uncover new TTPs. So again, this is not defined in an Intel document. We're just going to look for some novel activity and hopefully find something. And if we do, then we can, again, codify that, build detections on that, and improve our organization maturity. One big component I found with a client is that there's visibility gaps often. And you might not know that until you perform a threat hunt and say, okay, I want to collect PowerShell logs. Well, we don't have PowerShell logging. Well, let's improve that, right? So you find opportunities to improve the organization from a foundational level just by assessing your organization, seeing where we can collect from and where we have issues collecting from. And also, of course, not least, continual maturation. So we're trying to improve the organization. This isn't for everybody, so we like to think that organizations that do this are at a certain level of maturity, right? There tend to be, if you think of the crawl, walk, run analogy, they're typically walking or power walking at this point. And so when they introduce threat hunting, we're trying to get to that running level of maturity. So we're trying to improve that maturity and those detection capabilities. So here's a cute graphic about how to depict that. So there's a detection maturity pyramid here. The very bottom three are the ones that you need at a very basic level to perform threat hunting effectively at scale. If you are missing technology and tools, or you're missing use case and playbooks, or you're missing formalized security programs, you'll find issues with trying to introduce a threat hunting program pretty early on, right? So having a formalized security program, governance backed by executive leadership will help you get the buy-in you need so that when you do have some sort of, finding, malicious finding, people actually listen to your threat hunting team and actually follow along the remediation guidelines you provide. So having that is important. Use cases and playbooks, pretty self-explanatory, making sure I have my incident response plan if I need to kick one off, my communication matrices defined, so that if I do find something, again, I have a streamlined path to actually introduce the finding to the organization and they can remediate it. And then most importantly, probably, is technology and tools. Trying to threat hunt through email data without a secure email gateway solution, it's like good luck. Like you can try, I'm sure you can do it, but it's going to be pretty difficult to do, right? So making sure that you have your technology and tools in place in some capacity. There's going to be visibility gaps. There's going to be parsing issues. We find those, we uncover those during our hunts. We improve, again, improving the maturation of the organization. Some nice to haves, the dedicated threat hunters. I haven't ran into an organization just yet that I've worked for or with that had dedicated threat hunters, but that's the end goal eventually, is that you have resources assigned 8 hours a day, 40 hours a week to do this kind of stuff. What I often find is a hybrid approach. We have SOC analysts, 4 hours out of the day, they'll do threat hunting, right? Which is good, but also could be some issues, right? They might not spend as much time pulling on threads if they have to go back to their tier 1 triage analysis. So having dedicated hunters will help you a lot when it comes to threat hunting. And then lastly, integrated hunting program, so just making sure that you have your governance defined for your threat hunt program. Everybody's bought into it. Everybody's aware. You've evangelized this team. And so having that will, again, increase the detection maturity, so now that when I do find something, I can write the detections or tell somebody, my content management team in the SOC, you need to write a detection because the threat hunter found XYZ, right? So having all of that will be extremely helpful. So again, you want to be in that middle spot. You want to have those bottom 3 portions of that pyramid at the very least before you even think about threat hunting. Moving on to a quick methodology. So we decided we're ready. We have our secure email gateway, we have our IDS, we have our EDR solution, we have buy-in from an executive leadership perspective. Now we need to introduce how to hunt. This is a quick methodology you can use to perform that. So we'll walk through each one of these 5 phases: hypothesis, assess, acquire, analysis, and action. We'll walk through each one of these and show steps at each one, and then we'll walk through a case study, not even talking about theory, but showing actual raw data and what that looks like. So a hypothesis, this is kind of, if you ever did any Googling about threat hunting, you'll always hear about hypothesis. It's kind of the bread and butter of what threat hunting is. Everything starts and spawns from a hypothesis. So it's the foundational component of what we're trying to hunt for. And so we just need to think and theorize, get around a table and discuss what are our biggest threats, right? If we're in the healthcare industry, who's targeting that vertical? Or if we're just worried about a previous infection we had a year ago where we had to maybe pay a bunch of money to get that thing fixed or to kick the attacker out, maybe let's target that as a threat hunt and let's only target that threat actor or malware family, right? But it could also be broad. I mean, you can just say, I want to detect malicious PowerShell. It's pretty broad, but it's a great threat hunt opportunity. And so you can use a lot of inputs. You can use threat intelligence to derive that inputs. So again, if I have an attacker that has a new novel way of attacking an organization, I can use that as a model for my threat hunt, where I say, CrowdStrike said, you know, APT29 does XYZ. Let's model an APT29 threat hunt for those new TTPs, right? But we can also just be, again, broad. I put leadership as a maybe in there. It's kind of unfortunate when leadership drives threat hunts, but it will happen, right? Oh no, Log4j happened, let's kick off the whole team to go hunt for this stuff, even though we don't even know what's happening, right? So leadership kicked off, inputted, hypotheses sometimes happen. We try to avoid that, leave it to the folks that are on the ground floor doing this kind of work, right? But yeah, and again, it can include TTPs, threat actors, scope, all sorts of fun stuff like that. So what an example looks like is here. So this example is an example hypothesis about Fin11, who has been observed delivering maldocs to exploit the Folina vulnerability. They're trying to achieve remote code execution. And after they get RCE, they decide to deploy Cobalt Strike for C2 communication. So our hypothesis is, what if Fin11 has attacked our organization using these newly disclosed TTPs that bypassed our detection capabilities? Pretty straightforward. Some things to highlight here. We call out the threat actor, right? We're talking about Fin11 in this scenario. We call out TTP, so maldocs, CVE 2022-3190. We call out the fact that Cobalt Strike is going to be used as well. So we have a lot of things that we can kind of derive during the next process, or the next phase rather, which is that assess phase. So the assess phase is pretty important. We're going to model that attack path against our organization and find opportunities where we can collect artifacts from. So, okay, they decide to deploy, or rather deliver maldocs. How are they going to do that? Probably through email, right? So let's understand that we have an email gateway solution. We can collect artifacts from that. Let's make sure it's optimized as such. The logs are being parsed or they're being sent to a SIM, right? All these things we need to think about. So we map out the attack path from the attacker based on that hypothesis and derive opportunities to collect artifacts from. So once we have that intimate familiarity with the organization, we know where we can collect from. We also know where we might have issues, right? Went to a client, again, if they want to collect PowerShell logs and they don't have it, that's an issue, right? They didn't know that off the top of their head. They didn't know that. So once I got in there and did an event ID 4104 search in their SIM and got nothing, it's like, how am I going to hunt for PowerShell data if you don't have it, right? So having that familiarity will help a lot with being able to determine where in your environment you can collect those artifacts from. And then we're going to actually acquire that data. This is a very time-consuming portion because this is actually writing the literal queries you're going to run in your SIM, in your EDR solution, whatever the case is. And it's written as such because we want to have repeatable, iterable, measurable hunts, right? I don't want threat hunter A pulling different artifacts than threat hunter B from a week span, right? Like I did a hunt a week ago and my artifacts look different than your hunt that you did this week, right? We want to make sure we have the same hunts. And so this is a very time-consuming process because you will find parsing issues, you got to submit tickets to get those fixed, you might find permission issues, you might find all sorts of crazy things, and it can take quite a while to get this done. But when it's done, you do that legwork up front. Now, even if I have a new threat hunter come in who just got hired onto the company a week ago, and I give them my artifact collection queries, they can just execute it, and we have the same data sources. Very easy. And that makes it even easier when I want to allow list something, right? If I do a hunt and I find this service account, it's known, it's a threat adversary emulation service account, and I want to allow list it. I can just make one modification to my acquire queries and then share it to the team, and now again, we all effectively allow listed that service account. So it's very scalable and very helpful. And so you define all this stuff, you define your exact queries, and then the fun part happens, which is also one of the difficult parts, which is actually analyzing 700,000 rows of data, which is not very easy to do, right? So we might have, within that one hypothesis we just looked at, we might have 6 queries. We run 6 queries, let's say we get back, depending on the organization, 100,000 records each one. So we have 600,000 rows of data to hunt through, which again is why threat hunting is so hard, because that's pretty daunting to do. We're not waiting on our SIM to tell us this is bad, we're just simply looking through all of it. And so carving through CSVs manually, not the easiest thing, but Jupyter Notebooks will enable us to do this and to do it well. So let's talk a little bit about Jupyter Notebooks, which is a big portion of this talk. So all it is a web-based application. It allows you to transform, analyze, visualize data in a web-based platform. So if you're familiar with Python at all, which I was not a year ago, and I still am not, but I was able to leverage Jupyter Notebooks for this. So it's one of those things, if I can do it, you can do it kind of thing, right? Like, I'm not familiar with Python too much, and if you are, you can even do more cool and exciting things than what's being shown in this slide deck. So you rely on native Python to carve out your data. You can build enrichments because you can rely on Python to make API calls to enrich your data sets, whatever the case is, right? So one other cool thing about Jupyter Notebooks, besides the fact that you just use native Python to analyze stuff, is that you can embed instructions within Markdown language directly in them. So if I have a new threat hunter who doesn't really know what they're doing, they're just executing code blocks, I can have instructions that say, this is going to help you analyze parent-to-child relationships. And so once they execute it, now they know, at least at a foundational level, I'm looking for XYZ as an indicator of compromise of some sort. They might not understand the underlying code, which is fine because I can just share it to them. They can hit execute, and now they can look for artifacts of malicious activity. And so it's shareable. I can build one notebook that aligns with the hypothesis. I can share both the hypothesis and the notebook out to my team, and now we all have the same queries for artifact collection, and we have the same queries for analysis. So it ensures that repeatable, measurable, and iterable aspect of a threat hunt. So very cool stuff. High level, this doesn't do it service, but very high level of what that looks like. So we have our ugly black and white log file on the left here. We give it to Jupyter Notebooks. We pass in a CSV, a JSON input, whatever the case is, XML. And we can enrich that data, first and foremost. We can use premium intelligence services like Mandiant Advantage, which costs a pretty penny, but we can always use something like VirusTotal, which you can get a free API key for, and I've integrated it with VirusTotal as well. And so we can take a look at what we can get out of this, right? So if I have a bunch of file hashes in my data set, I can pass those file hashes to Mandiant Advantage or VirusTotal or any intelligence source you choose and get back scores that indicate, is this malicious or not? Is it benign or not? So instead of having to look through 600,000 rows to see if any of these files are malicious, manually copy and pasting these into VirusTotal. I can hook into an API using native Python because Jupyter allows that, and I can get quick wins real quick. This has a score of 100 out of 100, meaning it's malicious. So now I have a tipping off point that this user downloaded some malicious file of some sort, right? So we pass it to an intelligence service. We get a cute, nice, shiny log file in the middle there. And then we do further enrichment on that. So we can, again, rely on native Python at the bottom of your screen there. We can use some free services called Freak Server and Domain Stats. I'll walk through what Domain Stats actually is, written by a gentleman named Mark Baggett. Very, very good tool. And we can also use pandas. Pandas is a very big component of this. It's very useful and will help you visualize all this stuff. If you've done any Python visualization, data analysis, you've probably used pandas. And pandas will facilitate a lot of this for you. And so we give it multiple enrichment opportunities, and then we have findings. We hopefully have findings. If not, then we're going to have to do some more carving through that data set. But we can at least get some quick wins on using some of these enrichment opportunities. So I apologize if you can't see it in the back. It's going to be not too important. But in this instance, I'm just showing what a notebook might look like, right? So this is a Hou.Sec.Con notebook. We have Windows event log pandas queries at the very top. I'm using Markdown to indicate a new row of queries to run. And so now when the threat hunter gets this notebook, they can read it and say, oh, okay, these next log or these next queries are going to be geared towards PowerShell event log analysis. Moving down towards the bottom, they hit the new portion where it says WMI PowerShell pandas queries. Now I know I'm analyzing WMI data. So you can embed instructions, kind of sections within those. You can even put images if you wanted to, right? You want to put your cool logo in there, you can do that too. And in the italicized portion, I call out specific things that the queries are going to do. That very first italicized bullet point there is identifying a large number of PowerShell execution events by the Active Directory user. And so all it's doing is I'm using a pandas query to group by the user. And so all it's doing is it's going to collect a count of the number of users within my data set. So if I have a user executing PowerShell 50 times, it'll show up as XYZ user executed PowerShell 50 times. And so we can do some least frequently occurring analysis to look for when a user has a one-off PowerShell execution. Why is that, right? We can look at the user to say, are they in accounting? Why is the accounting user initiating PowerShell commands, right? Or are they in engineering? Then maybe we can omit that user, right, depending on what we're trying to accomplish. So a lot of cool things you can do. This is just a quick snapshot of what a notebook might look like. And again, we can just export this, and I can just email it out to the team, and now we have a full-fledged notebook. This is a small snapshot. It's probably like 10 times as much as this, with a bunch of pandas queries, enrichment opportunities, and again, very transferable to different threat hunters. So after we do our analysis, the last portion is we're going to take action. So action is just anything we do based on the findings we have, or lack of findings we have. So it could be a non-malicious finding, meaning a user just downloaded some AnyDesk they shouldn't have downloaded, or they're running as a domain admin and they weren't supposed to, right? We can uncover whatever the case is. We document that. It can also be malicious as well. So we want to initiate remediation tickets, get the ServiceNow team to, action these tickets to make blocks on domains, IP addresses, whatever the case is. But it also could be improving our future hunt iteration. So again, we have a user that is allowed to do something. Let's modify the notebook or the acquisition queries to just remove that user from our findings, or rather from our artifact collection, and it just saves us all time, right? So again, action is very important. One of the most important phases outside of, well, I guess everything else really, but yeah, that's going to be the all-encompassing portion where we're taking any actions based on what we're doing within our threat hunt. All right, so we walked through a quick HAAA methodology work through. So now let's go through a case study. What does that look like when we're talking malicious PowerShell? All right, so this is again, this is going to be live data that I used to do everything here. So our hypothesis is, what if threat actors are abusing PowerShell to live off the land, blend in with our normal day-to-day activities. And so this use case will focus around the hypothesis that a threat actor is trying to leverage PowerShell to install malware, establish persistence, and or initiate command and control communication. So they're trying to do anything and everything with PowerShell, and you'll tell, compared to our last example, this is pretty broad, and that's okay, right? We don't want to have our threat hunt be too narrow because we might miss stuff. You also don't want to have it be too broad because then you have too much data. So there's a happy medium there. It's not really defined, but in this scenario, we're calling out PowerShell as a TTP. We're calling out the malware installation, persistence, and C2 as portions of data sets that we're going to look through, right? So once we understand our hypothesis, let's assess where in our environment we can actually collect this data from. So they're going to use PowerShell to install malware. Windows Event ID 4104 is your PowerShell script block log. So I want to collect that data source because that will have execution events in them. We can also look at Windows Event ID 4688. That's our process creation events. If you have PowerShell command line auditing enabled, then you'll get even more granularity with that, right? You can look for things on the command line, for instance, so very cool. We can also look at our EDR alerts or EDR process creation events with PowerShell. CrowdStrike is a great source for this. CrowdStrike has all sorts of PowerShell data just sitting in their data lake that you can just collect from. So very cool stuff. You could do a simple string search for process creation and PowerShell and get back all these data points from the CrowdStrike data sources. And so that's for the malware install. What about establishing persistence? So again, CrowdStrike has a great thing called auto start execution points, or ASEP, where we can collect ASEP execution events that contain PowerShell. So we'll get all these events where somebody's trying to write to the registry in auto start execution points, so our run keys, our startup folders, things like that. If PowerShell is referenced in any way, shape, or form in those methods that attackers use to establish persistence, I get that data back. So we're going to assess, again, where in our environment we can collect this data from. And then also C2. One of my favorite things, again, as a network traffic enthusiast, I love the user agent string. I love that header because we can just look for when the user agent in proxy logs contains the word PowerShell. And then we can find all proxy data where PowerShell was the initiating user agent. So very cool stuff. We'll kind of focus on that last bullet point. Again, I love network traffic analysis, so that's what I'm going to focus on. This is an example query of what that looks like. So in this example, this is Splunk specific. So depending on what your SIM is, your EDR solution, whatever, you'll have to modify the queries, right? But we're taking the web data model, which is a built-in data model within Splunk, and we're going to look for when the user agent contains the word PowerShell. And if it does, give me the username, the action, if it was blocked or denied, give me back the source host, destination, domain, URL, and user agent. So not too difficult, right? This query is not too difficult to understand. The hard part is the data that's flowing into that web data model at the time had pretty much garbage data in it. So during the acquire phase, we were able to determine the web data model does not have the right source types flowing in it. So we had to work with the Splunk team to get the right data integrated into that data model so that I can then collect from it, right? So although it seems quick and easy right here, again, it's a very time-consuming process because you will find gaps, visibility issues all over the place. But yeah, so again, shareable. I give it to Threat Hunter B, and they have the same exact query I do. They get the same results, same field, same header, all that fun stuff they get back. So that is an example and one of many that will be associated with this use case of malicious PowerShell. And then we'll rely on pandas to do some analysis for us. We'll walk through a few analysis techniques here. And so pandas, again, I talked about a little bit, open source data analysis library, very useful to work with relational data sets. So if you have essentially CSVs, just relational data sets, table names or header names, very easy to work through. It can carve through CSV, JSON data structures, XML as well. It's very intuitive to a certain extent, as intuitive as a programming language could be, but very useful. And so we'll look at what that looks like. And so this is a simple pandas query we have our proxy data frame, which is just going to be a proxy data set, essentially. So after running that acquire query I just showed you, I have all my data. I pipe it over into a data frame within pandas. And now I can just look for when the user agent, the user agent and the user, the combination of the two. I can get a unique count of the combination of user to user agent strings. So I can look for the specific user and their user agent string and how many times it happened. So on that far right row, you see there's our column, there's a count column. It shows the number of times a combination appeared. So again, least frequently occurring analysis, I would look for the inverse of that. I would look for when a user has a one-off PowerShell query, or rather web request, right? That might be more suspicious than somebody who did it 12 times because they might be a developer of some sort. And so we get back some data. This isn't the best win, but this is just kind of highlighting some of the stuff that you can do with pandas. We can also use threat intelligence. Again, I guess I should say this to begin with. Kind of late. This is my thoughts. These are not Mandiant's thoughts. These are not U of H's thoughts either. Kind of late. Don't fire me. But yeah, so you can use Mandiant Advantage. You can use VirusTotal. You can use Threat Connect. You can use whatever intelligence source you want. As long as it has an API, you can hook into it, which is great for us because it's easy. It's relatively easy to do. So now that we have API access to Mandiant Advantage, because we get that premium intelligence from Mandiant, and we have some Python capabilities that we can use within Jupyter, we can just harmonize the two, and now we can make API calls against those domains that we have in our proxy data set to see, are any of these domains malicious? I can just feed those domains directly to Mandiant Advantage and it'll tell me. This is a hard to read slide. The point of this is that it is not, we're not hiding the code from you. The code is written for you right there. And so you can try to understand what's going on here, or you can just pass it to a threat hunter. They can just hit Shift Enter, execute the code block, and then it's going to prompt for their API keys. And so because I actually programmed it this way, it asks for your API keys. You give it your Mandiant Advantage key ID and secret, or VirusTotal API key, or whatever intelligence subscription you choose. Then at the bottom there, it's going to extract all the domains within our data set, put them to a new CSV, and then we just funnel all those domains through the API to Mandiant Advantage. Advantage is going to say, this is malicious, this is not malicious, or I don't know, right? But we get back quick wins. And so what that looks like is here. So we have a new data frame called our merged DF, merged data frame. This is just going to be a combination of our original data set and our enriched data set using Mandiant Advantage. And what we're looking for is when the M score is greater than 50. So we're looking for an M score. M score is simply the confidence level that something is malicious, right? VirusTotal has like a score of like out of 64 virus engines or whatever, antivirus engines. You can use whatever score you want, but Mandiant uses M score. So I'm looking for when the M score is greater than 50, give me those results back. On the far right, which I blow up on that bottom portion here, we see two new columns. We see a column for M score and a column for attribution. And so we see an M score of 100, which is I'm malicious, really malicious, and attribution of APT 29. And that's what you get with Mandiant Advantage. I'm sure VirusTotal has their own stuff as well. And we look at the destination domain, and it's avsvmcloud.com, which we might not all be familiar with. We probably should be. That's the kind of SolarWinds related domain. So this is real data, but I did put in that domain just for intents purposes here for the example. So luckily this isn't real. We didn't have any beacons to avsvmcloud.com, but it does showcase the fact that this data had AVSVM Cloud in it. I fed it to Advantage. Advantage said, this is 100% malicious, and we've seen this with APT 29. So instead of having to look through thousands upon thousands of proxy logs, I can feed it to Advantage, and I have a quick win. Now I look at who is the user that went there? What was the host? What have they done next? And continue along my threat hunt process, right? So quick wins, threat intelligence is great. We can also use domain stats, kind of mentioned that earlier. So domain stats is a tool written by Mark Baggett, a great gentleman who teaches for SANS. He has his own SANS class. He has a few tools out there. Domain stats is one of them. He also has Freak Server. He also has APIify, I believe it's called. So very, very smart guy. Domain stats gives us quick wins as well. I can feed it domains, and it'll tell me when was that domain registered. Right? Users typically, we're pretty static in nature. I go to Mandiant.com, I go to Google.com, I go to U of H or UH.edu every day, right? My normal thing. But if I browse to a random website one day that was created 6 months ago, that's a little fishy. Why did that happen, right? So I can use something like domain stats, feed it a bunch of domains, and it'll look up to see when was this domain created. If it was created within the last 6 months, that might be an investigation starting off point for me. So again, getting those quick wins. It'll also do high entropy domain, so it does frequency analysis against the subdomain. So if I have a subdomain that looks DGA, domain generated algorithm looking, kind of random characters and strings in there, it'll tell me this is high entropy, this looks a little funky. So I can look for DGA related domains as well. So very cool stuff, and this is free. It's completely free, which is great. All you need to do is get a server in Ubuntu LTS, just get a very lightweight server. You just install it on a server, have it running on an open port, and it'll just wait for data to come in. And so in this example, I have a base URL of 10.0.1.3, port 5730. This is an internal IP address that has, oh, the PC is running low on battery, by the way. That's not good. And so it's sitting on port 5730, just waiting there. And so all I need to do is take that same unique CSV of domains that I extracted and feed it against my domain stats server, and it'll spit out birth dates of domains. And so this bottom slide here on that very right, you'll see there's a column called birth date. That is a new column that domain stats provided, which allows us to look at when was the birth date of a domain that we care about, right? And so this pandas query, I'm looking for when the birth date is greater than 2018, meaning was it created within the last 4 years? And so I can get wins, right? So I have avsvmcloud.com popping up again because that was created in 2018. So it effectively gets caught by domain stats. So domain stats is a very good enrichment opportunity that can help us. And so, yeah, quick wins, right? It might not be, and there goes the laptop. That's unfortunate. We're just getting to the good stuff. Man.
Yeah, they forgot to plug in the power cable.
Now we're down to the talent portion.
Yeah, right now. Yeah, was that a question?
Yeah.
Sure. Sorry, what? That's a good question. Unfortunately, no. Unfortunately, no. It's a good question. This is somewhat proprietary. Not really, but kind of, right? So. How long did it take me to set up? So Jupyter, having your own Jupyter instance, you can download Anaconda, which is a well-known Python utility suite. You can install Anaconda, and you can have it locally running on your system within like 15 minutes. You can have Jupyter running on your system 15 minutes. The thing is Jupyter loads the data directly into memory. So you're sharing your current working atmosphere with Jupyter and loading data sets, maybe megabytes worth, several megabytes worth of data pushed directly into memory. So it can be a resource hog. There also is a tool or a kind of flavor of Jupyter called Jupyter Hub. It's free. And it is a centralized server version of it. So you throw it up in a server, and people just log into it. You can have several different threat hunters log into it and perform their analysis that way. And so how our deployment was is we had it developed in GCP. We had a Jupyter Hub server. We had enrichment servers that had domain stats, Freak server on it, and it had a one-to-one communication path with the Jupyter Hub instance. And users logged into the Jupyter Hub instance. They can make API calls against that enrichment server. They had internet access out to threat intelligence repositories, everything they needed. Jupyter Hub is not security-minded by default, so anybody can log into it, anybody can provision their own user accounts. So it'll take some research to get it configured to where it has lockout policies, you need access to request access, all that fun stuff. So, yeah, yeah. We're working on.
To get a power supply. So
Okay.
Unless you know it by memory.
Know it by memory, maybe.
I can put my laptop. You don't have a laptop as well.
No, we do not. Yeah, any other questions, I guess, since we have time while we're waiting for a power supply? Anything else?
You don't have it in a USB.
Yeah, what kind of power supply do we need, do you know?
Just a barrel, one with a barrel connector. Is that Dell?
Let's do it.
Yeah, it's kind of a funky connector.
Let's do it.
Looks like you have to pay 4 or 5. I thought it was just a circular connector, not a barrel connector. No, I looked a little closer now.
Oh, is it not?
No.
This is like a.
Yeah, I thought it was.
You can try it.
I don't think it was. Let's see. Oh, maybe it
I
is.
mean, that looks good to me. Yeah.
Okay, you might have saved us.
You're a hero. Yeah, yeah, actually, yeah. You're still a hero, though. I appreciate it. It looks like it. Looks like it. Let's see. You're okay with us just keeping this forever?
I'll be in trouble then.
That's right. That's right. Sell it.
What's it worth to you?
Not worth to me, worth to them, maybe a lot more.
You totally powered off. You didn't go to sleep.
Yeah, that's unfortunate. We're almost done, though. No power supply, so it died. But we got one. We crowdsourced one. So this gentleman in the front. Yes, we got one.
Would this be the one that fits?
We'll give him back in a second.
Yeah, we'll knock it out real quick. Awesome, I appreciate it. Yep, perfect. All right, 8 more slides to go. All right, sorry for the technical difficulties. We're right back. So domain stats, right? We have a birth date column that shows us recent domains that were created, which is very helpful for a detection standpoint because users don't browse to websites built a month ago, typically, right? So a good detection opportunity there. And just highlighting it even further, we have a bunch of domains. You see we have python.org built, and registered in 95. So there's a lot of stuff there, and that's a quick win for AVSVM Cloud because that was the newest domain in our data set. So very cool stuff that we can do with domain stats. All right, using some more pandas. Another cool thing that we can do is we can have a bad word list or a dirty word list for things that we want to see as noteworthy within our PowerShell command line, right? If I think of execution on the PowerShell command line, I might look for the word mimikatz, for instance, or from base 64, or encoded, or IEX. So we have a lot of detection opportunities there where I can just create a static list that could be, static but dynamic, right? As I find stuff, I can modify that list and improve it. And so we even can do things like regex matching for 1 or 2 letter PS1 files, 1 or 2 letter executables, 1 or 2 letter DLLs. I can look for IPv4 addresses with the regex as well. So we can do a lot of cool things. So what that looks like in practice is we have this bad words variable, and I'm going to look in the command line column, which has all the command line arguments passed on the command line, and look for when the string contains any of those bad words. And so I can get back quick wins about a lot of potentially malicious stuff. You'll often find adversary emulation PowerShell commands. You might find some admins doing some kind of weird looking things that fall in scope of here, but it's pretty high fidelity. If I have a huge base 64 encoded blob, it's probably worth looking into. The issue with this is what happens when an attacker uses a novel way to do something on PowerShell, right? If you've used PowerShell at all extensively, in any capacity, you know there's aliases for everything. There's shorthand versions of everything. So I can type in encoded on the command line to let PowerShell know I'm going to give it an encoded command, or I can type in E or ENC, or I can type in /E. There's several different ways to encall some type of command that we're looking for that might bypass our bad word list, right? And so in this scenario, this is, again, with real data that we did this with, we had a bunch of hits, but we came and validated those, and none of them were malicious. So we're kind of thinking in our heads, all right, well, nothing looks too suspicious just yet. But we can also use Python and pandas to help us. And so this very first line is we're going to take the string length of our PowerShell command and get a character count and store it in a new column called command length. If I'm a PowerShell guru, I will write a couple lines of PowerShell commands and I'm done. Maybe I have like 80 characters on the command line. But an attacker who's trying to push data directly into memory will have a huge base64 encoded blob, which if I do a string count of that, that would look anomalous to me. Because if I'm used to seeing people type in 80 characters or so, and I see a command line length of 2,000, that immediately stands out to me, right? And so I blow this bottom portion up on the next screen as well. But we see on the very far right, there's a command length column with 5,720 characters that were passed on the command line in one single go. The next runner-up is at 2,000. So this is less than half of what the first, malicious, spoiler, command looks like. So 5,000 characters easily stands out against our data set because our data set has the next lowest down, is 2,000. And so then we need to look at this, right? We do our normal analysis of let's decode the base64 encoded blob. What does it look like? Why did we not catch it on the dirty word list that we created? And so looking at it even further, at the very top, the attacker decided to use quotation marks to modify how they're calling the encoded parameter on the command line. So instead of having /E, they had quotation mark /quotation mark E quotation mark. And so PowerShell interpreted it correctly, but it bypassed our dirty word list because we weren't looking for that. And so writing that down as a threat hunter, that's one of our action items for our action phase of our methodology, is we're going to introduce a detection for that in our regex match in our dirty word list, right? So doing some cybersecurity, kind of working through this data set, it actually comes out to be a bootloader infection that was leading to Cobalt Strike. And so this was something that we detected because we just relied on native Python to do a string length count of our command line parameters. So we weren't reliant on one single detection opportunity being domain names or being the entropy of strings. We also have multiple techniques that we can use to give us a lot of coverage from a hunting perspective. So again, bootloader, it led to Cobalt Strike Beacon. Fortunately enough, the EDR solution blocked this from happening, but all the artifacts, files, domains were still not blocked by the proxy. The artifacts were left on the machine. The user had no idea what happened still. And so there's a lot of action steps we can take by catching this bootloader infection that bypassed most of our traditional detection capabilities. The EDR solution caught it, but a lot of those files were still remnant on the disk. We need to remove that, educate the user, right? So there's a lot of value. Even though it still was caught by EDR, there's still a lot of things that we can get out of this from our hunt. So we detonate the malware, we get the C2 domains, the IPs, submit requests to block those. Let's share that information with our vendors, tell the proxy, you need to block this. This is a malicious domain. This is a malicious IP. And it turns out, after doing some more digging into the user's browser history, it was a watering hole site that the user downloaded this malicious file from, executed the JavaScript, and off to the races the attacker was going, right? So we blocked the watering hole site. We talked to the user and let them know, don't download files that have the exact string match of your Google search. That's probably malicious, right? We don't want to do that. So we educate them on how to scrutinize the files they're working with. And if you have any questions, reach out to the threat hunt team or the SOC team, right? We educate the users. We evangelize our security program by telling the user, you're not alone in this. If you have any questions, reach out to us, right? And also we modified that Jupyter Notebook, right? They bypassed our bad word list. Let's improve it and have a match for it in our regex match now. So in conclusion, talked about a lot, had some bumps in the road with the power going out, but in summary, this is a very quick and dirty definition, not as over-engineered as that initial slide, right? So the proactive approach to hunt for adversaries that have bypassed our detection capabilities. Again, we're not waiting on a SOC alert. We're not waiting on a SIM to say, hey, bad stuff happened. We're just going to go and collect data and hopefully find something. It requires a very intimate understanding of blue team operations, attacker TTPs, threat intelligence, business processes, organizational boundaries. I've heard, I've interacted with some folks who want to become threat hunters as their first role in cybersecurity field. And I tell them, like, curb your expectations a little bit, right? Like, you're probably not going to do that, right? Because you need to have a lot of familiarity with how blue teams work, how detections work, how to write detections, how does threat intelligence facilitate this process. All those things are very important. And last but not least, organizational processes and boundaries. You got to be aware of what you're allowed to do, the jurisdiction you have, who to reach out to get something accomplished, right? Like to strike while the iron's hot. So if I have to wait weeks for remediation to happen, I mean, what are we doing here, right? So very important. And again, that threat model, the H4A, hypothesis, assess, acquire, analysis, action, very easy steps to follow, and it assures that repeatable, measurable, iterable threat hunt. And lastly, Jupyter Notebooks will help you a lot in analyzing large data sets. Don't just try to use CSVs and do string matches and Control F and find evil. Like, good luck. So using Jupyter Notebooks enables pandas to give us quick wins on string matches, dirty word lists, things like that. We can also rely on native Python to make API calls to enrich stuff using domain stats, Freak server, using virus total intelligence, whatever intelligence you have. So a lot of wins there. All right, that is it. Any questions?